Good afternoon. Another day means another video. It's time for me to start you off on the nitrogen cycle, the phosphorus cycle, and the sulfur cycle. Those are the things we're going to cover in this video. I wish I had some music for this, but can you think of any songs that have nitrogen in it, phosphorus in it, or sulfur in it? I didn't think so. So no music, no special effects, no surprises. Oh wait, I do have one. Hang on a second. These are my doggies. Come on up here, smile for the camera. This is Gretchen here. Oh, she's old. She's 16 years old. She's such an old girl. She's such an old girl. And then a couple years ago, we added this doggy here. This is Skid. Say hello, Skid. He's like 2 years old, and we call him Skid because he's got a skid mark on his forehead here. See that? Get up close to the camera. Show him your skid mark. Well, anyway, there's my doggies, Gretchen and Skid Mark. Sometimes you'll hear them running around. They follow me around all over the house. So they'll come in here right in the middle of when I'm videotaping. You'll hear their little jingle of their collars. Anyway, let's get started with the nitrogen cycle. Alright, well, let's get started with this nitrogen cycle. The most important thing for you to remember about nitrogen cycle is that it is powered by bacteria. Without bacteria doing their thing in the soil, the nitrogen cycle would not even happen. So when I tell you that the water cycle is powered by the sun and that the carbon cycle is powered by the sun, the nitrogen cycle is powered by bacteria. There's 3 different kinds of bacteria involved in the nitrogen cycle, and you need to be familiar with how all of this works. First, and probably most important, you need to realize where all the nitrogen of the world is. It's in the air that you breathe. It's in the air that you breathe. 78% of our air is nitrogen, and yet we have no organ system. We have no way of processing that nitrogen. We have no way of getting it out of the air and make it useful to us. The only way we get the nitrogen that we need is by eating plants, or eat the animal that ate the plants. And that nitrogen is important in the formation of proteins, especially, amino acids that build to form proteins. So we need nitrogen in our diet. Since we don't have a way to get the nitrogen, thank goodness we have these magical bacteria that do the work for us. So let's follow along in this diagram. It is on page 70. It's on page 70. Alright, so the first group of bacteria are called nitrogen-fixing bacteria. Nitrogen fixation is the taking out of gaseous nitrogen, N2, taking that N2 out of the air and fixing it into other chemicals like oxygen and hydrogen to form things like ammonia. Not just ammonia, but also nitrite could be here as well. Anyway, the point is that these bacteria take the nitrogen gas out of the air, turn it into other chemicals, and these bacteria are all found at or near the roots of plants. Well, that works out good because plants can use the nitrogen themselves. There are a couple other terminologies here that are also used. Assimilation. Assimilation is when plants take the nitrogen compounds, ammonium and nitrate, up into the body of the plant through the roots. Ammonification is the breakdown of biological nitrogen compounds into ammonium. And so this is happening back and forth. This diagram's a little bit confusing, but this is happening back and forth all the time. 2 and 3, 3 and 2. All right, now that we have the decomposers putting the ammonium back into the soil, we need to talk about how we can get that ammonium turned into something that's a little bit more usable. When you go to the store to get fertilizer, you don't usually go to get some ammonia. You go to get nitrates because that's what's in most of the fertilizers that we purchase. And that's important because plants can use those nitrates. So the nitrification process is one in which bacteria convert ammonium into nitrate and nitrite. They're called nitrifying bacteria. You got to keep these separate now. We got nitrogen fixing bacteria. They take the nitrogen out of the air and fix it into other chemicals. Then we have nitrifying bacteria that are taking the nitrogen out of those other compounds. And then we've got a third set of bacteria that need to take the nitrogen and put it back into the air that we breathe. They are called denitrifying bacteria. So again, if it takes memorization, just memorize it. But you've got to keep track of what all these different bacteria are. Key to the process, though. All right, and we've gone in a complete cycle now, haven't we? We went from the nitrogen in the air, it got into the ground, and it's all the way back into the air again. There are some intermediate steps you don't need to worry about. That's the big highlights right there. Nitrogen cycle. All right, let's do the next one. Phosphorus cycle. The reason we cover phosphorus cycle in environmental science is because of human activities. If there were never a human on this earth, there would be phosphorus that would weather and leach out of rocks, especially up in the mountains, and a little bit of that phosphorus would end up running off, and it would end up in bodies of water like lakes and rivers and even the ocean. But we speed up that process considerably, because the only way for us to get phosphorus, the chemicals that we need, is to mine it. So we dig it out of the ground. Here's a picture here. We're digging it out of the ground, and we put phosphorus into two major chemicals that we use phosphorus for. One is fertilizers, especially, farming, big deal. Adding phosphates in fertilizers is a big deal, helps crops grow better, and also in detergents and other cleaners. So as long as we are mining, digging up all that phosphorus, it's in these chemicals, and then we use these chemicals, that phosphorus doesn't get used up. There's always some that ends up either leaching into soil or directly running off because the fertilizer never got into the plant at all. And how about us at home? We use the detergent, we wash our clothes. Where do you think that water goes? It goes right down the drain of the wash machine, and it goes right down to the water treatment facility, and we have no technique that we use to take the phosphorus out of that water. So that phosphorus just ends up going right through this water treatment facility right into the St. Johns River. Why is that a big deal? Because when phosphorus accumulates in areas, it stimulates the growth of algae, and we can end up with something called an algal bloom. So that's a phosphorus cycle. If I asked you what's the sink for phosphorus, you would say the phosphorus is in the rocks. It's in the rocks. And ordinarily that's where it belongs, and everything would be fine, except we need to make fertilizers and detergents, so we dig the phosphate out of the earth, and that introduces it into other parts of the environment at a much faster rate than nature would have. And we'll cover algal blooms in another chapter. So, there's a lot more detail to what happens with eutrophication. But as far as the phosphorus is concerned, you just need to remember where the phosphorus is, what we do with it, and the environmental problem it causes. Sulfur cycle is next. Once again, you see what the main sink of the sulfur cycle is. The main sink is rocks. And ordinarily, there's always a release of sulfur into the atmosphere, usually by volcanoes, bogs and swamps, places where there's a lot of decay. You get that rotten egg smell. You know what I'm talking about. When you go into a swampy area and it's all smelly and everything, that's sulfur being released into the air. So that's naturally occurring. That would be happening anyway. But no, we need a lot of extra sulfur. And the reason we need it is because we've got to burn that coal. Coal contains a great deal of sulfur. If it didn't, we probably wouldn't have an environmental worry when it came to the sulfur cycle. But it does. There's a lot of sulfur in coal. In fact, one of the safety precautions to take against putting too much sulfur in the environment is we can actually take the sulfur out of coal before we burn it to make electricity. Problem is, that's a very expensive proposition, and there aren't too many power plants that are interested in spending the extra money to gasify. It's called coal gasification, to gasify their coal first before they burn it. All right, well, why do we care about sulfur getting in the air? Plain and simple. It's called SO3. This sulfate gets up into the atmosphere, and you can imagine we have SO3 here, and if you add H2O to that equation in the form of water vapor in the atmosphere, you end up with something called H2SO4. Anybody know what that is? I think I told you the other day what H2SO4 is. That's right, it is sulfuric acid. So our big problem here is that this acid forms up in the atmosphere and contributes to a problem that we call acid deposition. Again, a problem that we will cover in another chapter, but I wanted to let you know what the key, most important part of the sulfur cycle is environmentally. All right, I'm trying to make this quick. I did want to mention a couple other cations that we find in the environment in larger numbers than you would expect. That is calcium. We find calcium cations. They'll react in soil and take nutrients out of the soil because these are ready to react, right? They're ions. So they have, actually in this case, they all three have one electron that they need or two electrons that they need. So they'll react with chemicals in soil, and they can be leached by water into the soil. And so these chemicals can react with other anions that are supposed to be there, that are good for the soil, and cause salts to form and other chemicals. So I just wanted you to be aware that extra calcium, extra magnesium, and extra potassium are ending up in our soils as well, and it's making farming very difficult in some areas. In developing countries where they don't have a lot of chemicals that they can add into the soil to try to remediate it, that soil, they use it a few years and then it is worthless for many, many years to come. That makes it hard for these poor countries to feed their people. All right, I think that's it. Nitrogen cycle, phosphorus cycle, and sulfur cycle. And I think we got one more video to cover in this chapter, and I'll probably do that tomorrow. So bye for now.